Hello, sir. This is Anand Bhomik. Uh, Seeking apology at first because maybe I took some time. Uh, like I have received this email on the 30th May. Uh, Actually, I had an exam, but after that, last 2 or 3 days, I was not feeling well for my like. I had a uh, severe blood pressure problem. The fluctuation of the blood pressure. Due to that, I actually took some rest. Finally, I actually started working from the yesterday morning. I was just thinking about this PDF file. I actually download this PDF, and I just read like 30 pages. So uh, this is like I have got some information, and still I'm just continuing the reading. So it is taking some time for me, but I just got some ideas by reading up to like 29 and 30 page, and based on that I actually prepared a presentation. But as it is mentioned in the email that to uh, because you already have focused this table, you have shared this table also. So what I actually had done to find this PDF file, to find this PDF file, because I was trying for to get the data, uh, but I couldn't actually manage the thing. So what I did actually, at first I searched for this table. I just search for this table and I just create some snapshot of this table. At first I actually tried to uh, read the data using the Python, but finally I found that maybe it is tough to extract the data of the table from the Python. So what I actually had done, by taking the image of this file, from the this is the table which is actually mentioned in this PDF file, and I actually take the image from this file. So then I try to do something to learn by extracting the data from this image using the Python. So actually I I did this thing to get some data from this from the Python, and I actually finally extract the data into the CSV. So it took some time for me uh, to analyze the data. It is actually uh, working on the image, this image. uh, it's like the, if I just show the location here, uh, this is actually now in the image. If I just put it here, and the image name is actually the table. So if I do this thing, so if I now just run this code, it will actually extract that this data. So there are some problem in this data I found, but almost like the data comes quite a natural. So it's like I was checking how to do this thing to learn from the YouTube, and I took the help of the Perplexity also, the GPT thing, to learn and take some take some code from the GPT, especially Perplexity, to put the code in here, and finally I extract the data into the CSV file. I just made it in the CSV. So I just convert it into the CSV file. This is the CSV actually, if I want to say. And then I actually had to work quite a long. Maybe there are some process to extract the data. I don't know how to do so. I was just thinking that if there is a process, so it took some time for me, but finally actually I successfully did the thing, and there are some problem with the data, but I uh, just uh, recover it. And this is the table. This is not actually the full table. The full table is like the extracted table. This one is the full table. Yes, this is the full table here, what I have just extracted from this image. This is the image, and almost like the similarity, but in some cases I have to change some values, like maybe there are some values of the two columns were actually conjugated, and then I have to just separate and split the column in between, from one column to two column. Especially this two column was created the problem in the extracted folder. If I just want to show you here, in the extracted table, it creates some problem. So like yes, this one here, these two data actually 1 8 2 2 it actually comes. So then I had to do something to from the data thing, like the data tool. Using the data tool, I just split this data into two column, but rest of the other, like two or three data has some problem, but most in more cases it was almost almost like quite accurate after just doing this extraction from the Python. So now what was my plan? Like my understanding from the email, if I just go to the email, that to follow the GLSC framework. Okay, the GLSC framework, what I had to actually follow. So this is one kind of a global framework. I have to follow this thing. And uh, the main the main paragraph is here, that to calculation of the carbon dioxide emission based on kilometer driven, then multiplying this with fuel consumption divided by 100 kilometers and emission factor of diesel 2.6 GL as described in ISO 14083 GLSC framework. I was just thinking of like how can I do this thing if I can create an example. Like my understanding from this point is like, if I say I just created, I just thinking with my wife also regarding that how can I actually create this thing, how actually I could do so. She suggests me one thing, like if you think about the Posti. So what actually Posti did, like Posti has the daily delivery from maybe from Vasa to Helsinki. So maybe there are some routes to follow, there are some stoppages to deliver the product. So I was not thinking about the Posti as a name, but I think the Piccolo company, I always found their track to be just moving from Vasa to another place, and some from another place to Vasa. So I just created a story in somehow that Piccolo company, a prominent logistic company, is tasked with the transporting of 3000 kg of product from Vasa to Helsinki. The journey spans 350 kilometers. So like we know this is like the distance between the Vasa and the Helsinki, maybe 350 kilometers, and the company is committed to calculating the understanding the carbon dioxide emission generated during the journey. So based on this email, this is the sentences to calculate the emission. Will adhere to the ISO 14083 standard and the GLSC framework, which provides methodology for allocating emission along with the entire delivery route. So now we have to do this calculation. So total journey distance is 350 kilometer. So like fuel consumption is like the truck consumes 10 liter of fuel per 100 kilometers. So, and it is already mentioned that the fuel emits approximately 2.65 kg carbon dioxide per liter. So now we have to define the fuel consumption. How? What is the fuel consumption? So we have to just divide the 350 kilometer divided by 100 kilometer, because consumes 10 liter of fuel per 100 kilometer. It is actually like the maybe the GLSC standard. This is the standard. So it is defined that 35 liters is actually consumed. So to find the carbon dioxide emission uh, based on this, the 35 liters, the diesel, the fuel the required of 35 liters. So if we just want to now do the calculation of the carbon dioxide emission, what you have to do, that the 2.65 kg carbon dioxide per liter, it's actually just mentioned in this in your email, sir. So I just took this point here. So it's the GLSC standard. So 35 liter into 2.65 kg per liter. So if we just multiply this, so it's all about like the total carbon dioxide emission is 92.75 kg carbon dioxide. So now the what we have to actually define, the thing with calculation is how to allocate a share of emission to each delivery point. This is what I have to we have to actually like define. So here emission allocation for each delivery point, we have to think about the formula for direct ton kilometers. Direct ton kilometer, it is defined like the weight goods weight good tons into the distance travel kilometer. So we had this table, as there are like in the journey between Vasa to Helsinki, there are like three stoppage, main stoppage like Tampere to Jyväskylä, where the Piccolo truck is going to stop to deliver the product. So it is like as I have just chosen only this route, so it has just only taken the first five data from this table. We use the first five data from this table. It's almost like the distance that the data I was using from here, from this table. If I just focus on this is the data. There's the hub 1, the direct distance is 874.028 7.70. So I have just taken this 5 data up to 3, this 1 2 3 4 5, this 5 data to define the allocation of this emission for each carbon dioxide emission of carbon dioxide in each location. So now we have to now as in the question we have just mentioned that 3000 kg of the product is going from Vasa to Helsinki. Now we have to split this thing. First we are thinking of that unloaded goods to Tampere was 600 kg and it is mentioned here the allocation is 7.70% of total good. It's all about, I have taken this from this table. So now the we have to just calculate the direct TKM, and it actually defined based on the weight of the good, and which will be multiplied by the kilometer, which is 7.2. That is mentioned. It is mentioned here the 7.2 kilometer. So the TKM is like 4320. So now I have defined the emission allocation for Tampere. It's like I have to divide the weight, the 600 kg divided by the total weight, the 3000, into 92.75 kg carbon dioxide. 92.75 we already have, it is already determined from the total carbon dioxide emission. So the calculation, what I have understand from your email, sir, maybe this would be the calculation. So the emission calculation for temperature, what I have actually determined, this is the 18.55 kg carbon dioxide. So and after that, it is also defined in the second phase, the emission calculate allocation for the Turku. This is 24.8 kg carbon dioxide, which has been just allocated. And the final thing is like this, all about if individually the uh, emission allocation which has been just determined, if I just now add this 4 kg of carbon dioxide emission, it would be the result of 92.75. So what we have to actually define, what I understand from your email, maybe maybe I'm sure that it is quite, maybe it is right. If it is not, then definitely, sir, you will give me some good advice. But what I was just thinking, maybe this is the process to define the emission allocation for each stoppage with this formula. So after that, I was just thinking how to do this thing into the Python. So I just tried to do the same thing into the Python. This is, I just prepared a carbon dioxide emission, and what I have done, just I just take this table, the table which is actually containing the data from this image. Just I have taken what I have just mentioned in the story. Based on that story, this 5 row has been selected from this table to for this calculation. So I have just prepared this table into the MySQL database, and I connect the database with my we connect the database into the Python, and then I call this data the query here, and then I had to do the calculation. What is the calculation? This calculation actually done here. Total distance 350 kilometer, and fuel consumption per kilometer is 10, and emission factor is 2.65, which was actually given. So total fuel, how to define this thing, this calculation is actually here. The main calculation, this thing is actually here. It is actually calculated here. This one is actually calculated. So then in the next, I was just planning for to create a graph on this. So it actually fetch the data from MySQL database and do this calculation, and we just create some function to define the cities here and the emission allocation. That is actually already another function already mentioned here. I just do this task with the help of that how to do this thing using the GPT thing also, and I found some code almost like same thing into the almost I got some view from the GitHub also. I found there is one guy from he is from Sweden, maybe Sweden or Germany. He has this sort of thing. So I got some ideas from the GitHub, the data, the coding thing from there also. I learned some features of him, some discussion there. So I just copied the thing and put the city name here and calculation thing here. So this is something like a his work was actually not for the carbon dioxide emission. He was actually working for the a single the product thing for the baby product. It was like a, I cannot now remember where is the, it is in the GitHub, but he actually did the thing for the diaper thing for the baby, that how long the diaper is going should be changed by the parents of that baby uh, when it requires, they travel from one place to another place, quite a long place. So it seems something like I found something familiar there. So I was thinking like maybe it should be something. So then I took the help of the GPT thing on that particular code and get this thing. So what I was thinking to create a animated graph. So I just call this function, and now if I just run this code, so what would happen actually? uh, yeah, exactly. This actually graph has been created. Okay, so I found the emission allocation. The Helsinki has the highest emission allocation for this journey. So I just wanted to put this into the graph thing, and yeah, I don't know that if everything is okay or not, but I tried. I guess so. Like uh, maybe I need some next time. I need some more suggestion and advice from you, sir. Kindly, uh, if there is any mistake, definitely I am expecting some guidance from you. Thank you, sir.